Hello and welcome back to another video. This problem, we have g of x is equal to x over e to the x. And we want to say, okay, for the nth derivative, what is going to be the form of that? And the way we're going to do that is by finding the first derivative, second derivative, third derivative. We're going to keep doing that until we start to see a pattern where we can plug in for the nth derivative. So the first derivative, using the quotient rule, because we have a fraction here, we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. This is over the denominator squared. So we have e to the x times the derivative of x. The derivative of x is 1. Let's just write this up here. We're going to have to do the derivative of x is 1 a lot. The derivative of x is 1 because it's a linear term, so the derivative is its coefficient, and since this is technically 1x, the derivative is 1. So we have e to the x times 1 minus x. The derivative of e to the x, another thing we can write up here, by definition, is just e to the x. Its derivative is itself, over e to the x, e to the x. And this is, factoring by grouping up on the top, we have e to the x times 1 minus e to the x times x. So you can pull out an e to the x out of both of the terms, over e to the x, e to the x. These cancel, and we get negative x plus 1, flipping those around, over e to the x. So that's our first derivative. No way to tell a pattern yet because we only have one. But finding our second derivative, we can do the same thing. We can do the quotient rule. So we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. This is equal to e to the x times negative, the derivative of x is 1, so negative 1, plus the derivative of a constant is always 0, so just plus 0, we don't even have to write that. So then plus x minus 1, derivative of e to the x is just e to the x, over e to the x, e to the x. Factoring again by grouping, we have e to the x times negative 1 plus x minus 1 over e to the x, e to the x. These cancel and we get x minus 2 over e to the x. And you might start to see a pattern here, right? We have, looking similar, there's some negatives that are all messed up, but we have for the first derivative, we have a plus 1 here. We have a second derivative, we have a minus 2 here. So hopefully we should see a 3 in the third derivative. But calculating the third derivative, similar thing here, quotient rule, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared is equal to e to the x times the derivative of x is 1 minus the derivative of 2 is 0, so 1 minus 0 is just 1, minus, we can think of this as plus, distributing the negative there, negative x minus negative 2 is plus 2, derivative of e to the x is e to the x, time over e to the x, e to the x, and this is equal to, again, you should be used to factoring by grouping now, we have e to the x times 1 plus e to the x times negative x plus e to the x times 2 over e to the x, e to the x. These cancel and we get 1 plus 2 is 3, so we have negative x plus 3 over e to the x. So now you can see the pattern. But if we say, okay, so g n of x, its denominator, it's going to be a fraction, right? We see that's the fraction. Its denominator is going to be e to the x on its own. Okay? And then we either have negative x or x. How do we tell which one's which? We notice, okay, when x, or when n is odd, 1 and 3, then x is negative. And when n is even, so we can think of g of x as just g to the 0th derivative, 0 and 2, x is positive. We can put this in the form that makes it line up with all these. And then we have minus 0. You'll see why. we have x minus n, except it's negative if it's a odd derivative. So how do we figure that into the equation, right? So we have x minus 0, perfect. X minus 1, well, not quite, it's negative x minus 1. Then we have x minus 2, perfect. Negative. And then we have x minus 3, no, it's actually the negative version of that. Well, this is going to be sort of a general thing that you can take. This is going to come up a lot when you're switching back and forth between the positive version of something and the negative version of something. We can use the function -1 to the n. By putting this out in front, when n is even, so let's say -1 squared, it's going to be 1, so it's the positive version of it. And when it's odd, it's the negative version of it. So this is just something that wouldn't probably come to you if you didn't know about it, but just to keep in mind in the future to use it. And this gives us our final form of the nth derivative of g of x. As always, thank you for liking and subscribing, and I'll see you in the next video.